Part 1 was about asking well. This one is about fixing. The two jobs that eat most of a real week. A screen that isn't quite right and a bug that shouldn't exist. Both have a move most people don't make. And then, at the end, the habit that decides whether any of this costs you 5 cents or $5. Let's start with the easy win, because it's the one people skip. Something looks wrong on screen. What most of us do is write a paragraph about it. The spacing on the card is off, the button color doesn't match the one above, and the label wraps at tablet width. That's 3 sentences of translation work, and you're the lossy part. Cursor's guidance is direct. Screenshotting an error state or unexpected interface and asking the agent to investigate is often faster than describing the problem in words. And there's a mechanical reason it works. Screenshots reach the agent as images, not as text descriptions, so it reads the layout the way you do, spacing and alignment and all. It goes further than debugging, too. Paste a design mockup and the agent will match layout, colors, and spacing against it. So the rule is short. If the problem is visual, send a picture. If you have a target, send the target as well. Words are for intent. Pixels are for state. Better still, stop being the messenger entirely. Cursor's agent can drive a real browser. Navigate, click, hover, fill in a form, scroll, screenshot, and read the console and the network traffic. That closes the loop. It changes something, loads the page, looks at it, and finds its own error in the console without you copying a single line. 2 details worth knowing. Browser logs get written to files the agent greps selectively, so a noisy console doesn't flood your context. That's deliberate. And browser state persists across sessions in a workspace, cookies and local storage included, so you aren't logging in again every time. Then there's design mode, which inverts the whole interaction. Click an element in your running app and just say what you want. The agent gets 2 things: the element's actual identity, its component, its styles, and a screenshot showing where it sits on the page. Circle a region with your mouse to point at it. Select 2 elements and say, make this one match that one. And you don't have to wait. Send an edit, notice the next thing, send that as well. They run in parallel. Right. Your turn. A drop-down closes the instant you click inside it. You can reproduce it every single time. You've read the component twice and you have no idea why. 2 options. A, paste the component into the chat and ask for a fix. B, switch to debug mode. Which one? And more importantly, why? B, and the distinction matters more than the answer. Option A asks for a guess. Debug mode goes and gets evidence. Here's the loop, and it's 6 steps. 1. Instead of reaching straight for a fix, the agent reads the code and writes down several competing hypotheses about what could be wrong. 2. It instruments. It adds log statements that report into a local debug server running inside Cursor. 3. You reproduce the bug following its steps, so what gets captured is real runtime behavior rather than a theory about it. 4. It reads those logs and identifies the actual root cause from evidence. Variable states, execution paths, timing. 5. A targeted fix, usually a few lines. 6. You reproduce once more to confirm, and then it strips out every log it added, so you're left with a clean, minimal change you can ship. Use it where it earns its keep, something you can reproduce but can't explain. Race conditions and async timing, performance problems and memory leaks, and regressions, where this used to work. For a plain stack trace, you need none of it. Paste the trace, say when it happens, and go. Which brings us to the one genuinely dangerous habit in all of this. Do not accept a fix you don't understand. An agent can hand you a plausible change that makes the symptom go away without touching the cause, and that is strictly worse than the bug you started with, because now it's invisible and it'll come back somewhere else. So keep asking, why was that value null? What put it there? Is this the root cause or a guard around it? Until you can answer, you haven't finished. The pattern under all of it is bring real data, terminal output, console errors and the failed request, explain analyze on the slow query, Sentry or Datadog through an MCP server, so production reality reaches the agent directly instead of through your memory of it. Agents perform best when they have a clear target to iterate against, so give them one. And that's a design decision you make, not something you hope for. A typed language, a configured linter, a test that fails. Each of those is a signal the agent can check itself against without you in the loop, which is exactly why test first works so well here. Ask for the tests from your input-output pairs. Confirm they fail before there's any implementation. That step is not optional. It's how you know the test is real. Then ask for the code that makes them pass and let it iterate until they do. And whenever you fix a bug, write the test that would have caught it. You just paid for that knowledge with your afternoon. Bank it. One last review habit. After generation, review, then find issues for a line-by-line pass, and ask for an architecture diagram before a big review. The structural problem is easier to see drawn than read. Last one. You've been in the same chat for 2 hours. It's the same feature, it's going well, and you notice the agent has started forgetting a decision you made near the beginning. Do you A, start a fresh chat to clear it out, or B, stay and restate the decision? Careful, this one is a trap. It's B, stay, same task, same thread. What you're seeing is summarization. When the window fills, cursor compresses the conversation to leave room to respond, and detail gets thinned. But it keeps the history as a file it can search, so restating the decision or pointing back at it is a cheap repair. Starting over would throw away everything that's still relevant and make you pay to rebuild it. Which leads into the money, and you already know the rates from the last video, so this is purely about behavior. 4 habits. 1. One thread per task. The whole conversation is resent every turn, but after the first time, it's a cache read, a fraction of the price. 2. Don't push what the agent can pull. Every file you paste is paid for on every later turn. 3. Prune your MCP servers. Their tool descriptions can be sitting in your context before you've typed a word. That's where that 47% came from. 4. Match effort to difficulty. A high-effort variant isn't a different price list. It thinks for longer, and thinking bills as output, the expensive meter. Save it for a problem that's already beaten a cheaper model. That's the pair, then. Show the agent what's broken instead of describing it. Make it prove the cause before it's allowed to fix it. Never accept a change you can't explain, and treat your context window like it costs money, because it does. Screenshot it, instrument it, test it. Thanks for watching.